Hey, hi, welcome again. This is Rajat. So in today's class, we are going to discuss system design of YouTube. As you know, YouTube deploys to billions of users, right? And these billions of users are located worldwide. Some users are watching YouTube from India. Some people are watching it from Russia. Some people are watching it from US. Some people are watching it from Europe. So how does YouTube handle this scale? Making sure that they are able to provide these videos at low latency and able to provide very, very less buffering time and making sure that everything is going very, very smooth. So that is what we are going to discuss today, is going to discuss the system design of YouTube, right? So before I go into each topic, let me just quickly share the agenda of the session today. So we will start up very quickly with just designing YouTube for a single person. Once we have designed YouTube for single person, we will go about scaling YouTube to billions of users. As we start scaling this to billions of users, you will understand that we will majorly face two problems. And once we solve these two problems, we will be able to design a system that can scale to billions of users and be able to stream videos very, very effectively, right? So I think the agenda makes sense. With that, let's start the today's lecture. So let's start with the first point is let's start designing YouTube. For a single user. Now let's see, like, what is YouTube? YouTube is essentially a video streaming platform, right? So let's say very, very, very simply, let's say this is the YouTube server, right? In a very, very simple sense. And this is the user's device. Right? Now let's say there is a video associated video here, which the user wants to buffer. So in the very, very approach one, in the very, very brute force approach, what can be the first very, very brute force approach is very, very simple. The first thing that the user will do is download the complete video. Once the whole video is downloaded, then the user will buffer the video, right? Very, very simple. Now, what are some of the advantages and disadvantages you see in this approach? Let's try to figure those out as well. So let's talk about the advantages and the disadvantages with this approach. Tell me, what are the advantages? One advantage that I see a very good advantage here is once the video is completely downloaded, there will be no buffering time, right? So the buffer time will not be there, which is a very good aspect. You will just see it in a minute. How do we go about using it? However, what is the disadvantage of this approach? The disadvantage is that the download can take a lot of time, right? When will the download take a lot of time? Download will take a lot of time if the video size is big. Does this make sense? Let's say if the video is only of 5 seconds, then the download will not take a lot of time. But let's say if it's a 1 hour video, then downloading of that video will take a lot of time, right? So these are some of the advantages and disadvantages of this very first brute force approach. Let's take the good parts of this approach and let's try to minimize the disadvantage of it and move to approach 2. This approach 2 is famously known as chunkification. So what is chunkification? Chunkification says is Let's say if this is my complete video of, let's say, 1 hour. What will I do is I will divide this video into small parts, right? So I will divide this video into these small parts. Each part here is known as a chunk, right? And each chunk is around 5 to 10 seconds long. Now let's assume that this is your video. Now chunkification process has automatically divided this video into multiple chunks. For example, this is chunk 1, this is chunk 2, this is chunk 3, this is chunk 4, this is chunk 5, and similarly, let's say this is chunk 105, right? And this is now your client. Now the client does not download the whole video, but essentially it starts downloading chunks. So it's download chunk 1, right? And then it plays chunk 1. And while chunk 1 is getting played, it then downloads chunk 2. And then subsequently chunk 2 is played. Then essentially chunk 3. So similar, now what is happening is, in the approach 1, which I was talking about, you are already taking the advantage that the buffering time will be less, because you have already downloaded one chunk, and while that chunk is getting buffered, there will be no buffering time. And you are also overcoming the disadvantage, because the video size, the each chunk size is very small, only 5 to 10 seconds, right? So this is how right now with chunkification you can do, right? Of course, a very major improvements on top of the first approach that we were discussing. However, still we can still improve a lot of areas. Let's also take a look at those. In approach 3, one more thing that we can do on top of it is, as of now in approach 2, we are downloading one chunk at a time. However, do we need to download one chunk at a time? Can we download multiple chunks at one time? We can, right? Obviously, we can download multiple chunks and then play chunks in sequence. So now in approach 3, what we are doing is, if this is our video, which is already getting chunked into multiple small chunks, then the client does not just send the request for downloading one chunk. Maybe it sends the request to download 5 chunks at a time, right? So the client will send the request of downloading 1 chunk, 2 chunk, 3 chunk, 4 chunk, 5 chunk at one particular point of time, right? And then all of these are async requests, which are happening in parallel. And then you are playing downloaded chunks one by one. So what this will make sure is that the chances of you getting buffering, because chunk 2 is not downloaded and chunk 1 is completely playing, will happen very less. So this will again make sure that your buffering time is reduced on the overall video, right? So this is again a very good aspect. However, when you do this approach, you will face one problem if you are able to identify it. One problem that you will face because of this downloading of multiple chunks at a time is, how will you make sure that the order is maintained? How will you make sure that the order of chunks are maintained? This is important aspect, right? How will you make sure that the orders are maintained? Why do I say so? For example, let me give you an example. Let's say this happens, that this is your video, there are these multiple chunks, and this is your client. The client has sent the request to download 5 chunks at a time. Now the chunk 1 gets downloaded, the chunk 2 gets downloaded, but the chunk 3 download failed, and the chunk 4 gets downloaded, the chunk 5 gets downloaded, and right now chunk 6, chunk 7, chunk 8, chunk now is in progress of getting downloaded. Now tell me what will happen. Since you said that you will start playing downloaded chunks one by one. So you will play chunk 1, then you will play chunk 2, and then you will skip chunk 3 and directly play chunk 4. You tell me whether this is the right thing in a recorded video or not. Can you skip some chunks of videos in a recorded when you are playing a recorded video? No, right? That is not something that can be done in a recorded sense. So skipping of chunks is not allowed. Right? So that is a problem, that how will you make sure that the order of the chunks are maintained, right? To provide the solution of this, there is a approach, or there is a file that is known as a manifest file. I think you might have heard about it. But what happens, what is a manifest file essentially is that manifest file is just a simple file which contains the order of the chunks. Right? For example, it contains, okay, chunk 1, first chunk 1 is there, then chunk 2 is there, then chunk 3 is there, then chunk 4 is there, then chunk 5 is there, and similarly, what is the order of the chunks is written in this manifest file. So now what happens is, on the YouTube server, with respect to every video, there will be a manifest file, right? So there will be a chunkified video, of course, and then there will also be a manifest file associated with this video, right? Now the user, the first thing the user will does is it will download the manifest file. Even if you open your network tab and play this video again, you will see that the first thing that gets downloaded is a manifest file. This manifest file just contains the order of the chunks that there are. Then you will start downloading multiple chunks, or let's say 5 chunks in parallel, and then play the beat. Play chunks. However, while you are playing chunks, you will see, you will check from the manifest file. What will you check? You will check, okay, this is your manifest file. So chunk 1 is downloaded and played or not. Let's say this is downloaded and this is played, and this is chunk ID, right? Chunk 1 is played and is downloaded. The chunk 2 is downloaded and is played. However, the chunk 3 is not downloaded. The chunk 4 is downloaded. The chunk 5 is downloaded. So when you come to chunk 4, playing of chunk 4, you will see whether the previous chunk of chunk 4 is already played or not. If not, you will only buffer. You will not play chunk 4, right? So you will make sure that only play a chunk when the previous chunk in the manifest file is already played. And this is very, very important while you are making sure that you are creating a method to create YouTube for a single user. Does this now make sense? Like, how can you create a video streaming kind of platform at low scale? Video streaming platform like YouTube, just for a single user. What we discussed in this, we discussed the very first approach, the approach 1, the very first brute force approach, in which we downloaded the whole video and then played it. In approach 2, we made corrections over it and we used a chunkification approach with one chunk downloaded at a time. Downloaded at a time. In approach 3, we further improvised upon it and we again do chunkification, however with multiple chunks in parallel getting downloaded, right? And finally, in approach 4, we understood the problem of maintaining order in the approach 3. So we did chunkification of parallel download with a manifest file. This approach, final approach, makes sure that you are able to stream a video like YouTube. Like you will create a video streaming platform like YouTube for a single user. Does this make sense? A quick yes. Now we will talk about, once you have this fundamental created for a single user, now we will talk about how to scale to billions of users. Okay. Essentially, now as you start going to scale to this user, you will eventually see that there are 2-3 problems, like essentially 2 major problems that you will see. I will discuss these problems in detail and then we will come to the solution to these problems. The first major problem that you will see when scaling this is how will you make sure that the latency of the video is low at scale, right? Latency means how much time it is taking for the video to again like buffer, to load, etc., right? Essentially, how much time it is taking for the video to load and buffer should be less at scale. This is the one problem you will face. And the second problem that you will face is how will you handle high bandwidth. We will first discuss both of these problems, really understand what these problems are, and then we will come up with the solution to these videos. However, before I come to the solution of it, if you are someone who is new to the channel and have joined and is watching the first video for the channel, then do consider subscribing and liking the video if you find this useful, and do share it with some of your friends if this adds value to them as well in learning new concepts. Let's start with the first problem, which is latency of the video. If you see, right, if you actually see, then what is the problem with scalability? The problem with scalability is that users are located all around the world. Or maybe, like, just to help you understand better, let me scope down to only India, right? Let's say this is India. I am not very good at drawing things, but yeah, I think let's say this is India. So let's talk about AWS, right? AWS has data center in Mumbai, in India, right? So let's say this is Mumbai. You have the AWS data center here. So let's say YouTube uses AWS as their data center. So the video is hosted here. And let's say I am in Delhi, right? So to watch this video, I have to go to Mumbai and stream video from Mumbai, which will increase the latency, because as the distance between the user and the place from where the video is getting streamed increases, the latency is going to increase, right? So that is the first problem with the latency aspect. The first problem is, of course, that your video is getting streamed from a long distance. Do remember that there are not a lot of data centers in India. AWS, I think, have one data center in Mumbai, and they have recently added one more data center, right? Azure have only one data center in Hyderabad, which again is added recently. So there are not a lot of data center. So someone from Delhi have to come to a very long distance to render one video, which will increase the latency. And the second is the video might be the video that the content creator uploaded can be in, let's say, 1080p or 4K, right? But your internet bandwidth, the user internet bandwidth, is slow. Let's say they are on their mobile device. Let's say they are on a 3G network or a 4G network or a Wi-Fi, which is somewhat slow. So how will they be able to render a 4K or a 1080p video? That is another challenge which cause high latency at scale. Because at scale, you will see different type of users and different type of internet bandwidth that they have as of now. So this is the one problem that we will have to solve, is the latency problem when we talk about scale. Let's discuss the second problem as well. The second problem is of high bandwidth. What do I mean by high bandwidth? High bandwidth, by which high bandwidth I mean is, let's do some estimation and you will get the sense of it. Let's do some very, very small estimations. So what do you think, how many number of users do YouTube have? Let's say 2 billion. Let's say there are 2 billion users on YouTube. How many users are daily active users? Like people who are watching video on a particular date, right? YouTube being famous, let's say 20% of them are active on a daily basis. So that will be 400 million. What do you think, how many number of videos a single person watches in a day? Again, as an estimation, let's say 10 videos, right? So how many total videos are watched per day? It will be 400 million users are there, and each user on an average is watching 10 videos. So that will be 4 billion videos in a day, right? Which is very, very high. Now, what do you think, what will be the size of each video? Let's say the size is 20 minutes, right? Let's say each video is around roughly 20 minutes long. What do you think, what will be the watch size? What do I mean by watch size is essentially, not everyone watches like the complete video on YouTube. For example, some of you who might have started watching this video might have dropped by now. YouTube is a platform which shows a lot of thumbnails, a lot of content which appears appealing to you, and you leave the video in between, right? So let's say the total video that is watched is on an average is 10 minutes of worth time, right? Then how much is the total watch time per day? The watch time per day will be 4 billion videos in a day into 10 minutes of each video. So that will be 40 billion minutes of watch time each day, right? Let's say 60 minutes of video or a 1 hour of video is, let's say, 5 GB. Then how much is the total bandwidth required per day? Or not like bandwidth, how much total download will happen per day? It will be 40 billion minutes, right? 60 minutes take 5 GB. So how much will 40 billion minutes take? It will be 5 GB by 60 minutes into 40 billion minutes, right? If you cut minutes by minutes, cut this by this, make it 2, make it 3, right? I'm just, this I am making it as 10, and this I am making it as 3. So it will be 3 billion GB, right? So total download each day will be 3 billion gigabyte, right? What is bandwidth? Bandwidth is total download per second, right? So this is in a day. So what will be per second? Total billion GB by number of seconds in a day, which will be 24 hours into 60 minutes into 60 seconds, right? Let's do this calculation quickly. 1000 into 1000 into 1000 into gigabyte. This is a billion into 24 into 60 into 60, right? Let me cut this by this. Let me make it just 25, right? And cut this by 40. Let me make this 2, and this will become 12. And let me cut 12 by 10, since I'm just doing some estimations. So this will become 40 into 1000 gigabyte, which is 40 terabyte per second. This is the bandwidth requirement at the YouTube side. Like, what does it really mean is that if this is the YouTube server, right, and these are all the users which are streaming videos from YouTube, then a lot of these users are streaming around 40 terabyte per second, which is very, 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 very huge. So how does YouTube is going to handle this much of very, very high bandwidth is another challenge that comes in front of you, right? These are the two challenges that is coming with scalability. One of that challenge is latency. Latency caused by two reasons. One being that internet speed of user, and the second being the location difference between user and server, and the second being the high bandwidth requirement. If you solve these two challenges, then you will be able to successfully create a YouTube system or a video streaming system at scale, right? So let's quickly solve these two problems and try to understand how can you then build YouTube for scale. Coming to this first challenge, this challenge you would have already seen. This is not something that is in control of YouTube, right? Like, what will be the user's internet speed is not in the control of YouTube. So they cannot control it. Only thing they can do is that they can provide videos at different dimensions, right? That is why you will see that every video is in different dimension: 240p, 480p, 720p, 1080p, 4K. And then based on the user's internet speed, the right video is shown to them with the right dimension. That, okay, the internet speed is slow, let's show him 480p. The internet speed is very fast, let's show them 4K, right? So this is how this problem is solved. Now, how does this problem is solved? This problem is solved using, or this problem and this both problem, this and this, both of these problems are solved using something known as CDNs. CDNs are known as content delivery networks. Now, of course, I cannot cover CDNs in complete details today. If you want us to cover CDNs in complete details as well, do let us know in the comment section, and we will create a new video on what are CDNs in a very, very good detailed format. However, just to give you a very, very short gist of what CDNs are essentially small servers These small servers are known as edge servers. These edge servers are distributed all across the world. Right? So these are like, let's say in India. So there might be just one AWS server, AWS data center in India, but there will be a lot of edge servers in different places, distributed all across. Right? So these are kind of chain of small servers which are distributed all across the world. Edge CDNs are provided by CDN providers. There are multiple CDN providers. For example, Akamai is a very famous one. CloudFront is by AWS only. AWS CDN systems are CloudFront. Since there are a lot of these small servers all across the Gulf, all across the world, these are expensive as well. CDNs are expensive as compared to AWS servers. However, let's try to understand how a CDN is able to help our problem. How CDN help here. Now, since these are small servers distributed all across the world. So let's say if I am someone who is buffering from Delhi, right? Then there will be a CDN in Delhi as well, or in a nearby location, right? Or if someone is from Punjab, then CDN will be in Delhi only. So now the distance from where the user is buffering the video is very reduced. Earlier, the user was in Delhi and he was streaming video from Mumbai. Now the user is in Delhi and he's buffering video from Delhi only. So the distance between the server from where the video is streamed and the user is reduced, and that will reduce the latency. Reduce distance between user and streaming server resulted in reduce time/latency. So that is one thing. How does the CDNs helps in the bandwidth? Let's also see that. How CDN helps in bandwidth. Right? So now, since again these are small servers distributed all across the world. So now, instead of one system handling the overall bandwidth, there are these small servers which are together handling the overall bandwidth that is required to be served by YouTube. So if to give you an example, as far as I remember, I might be wrong here, right? As far as I remember, there are around 3.6 lakhs edge servers that Akamai have. If I was wrong here, we will let you know in the like in just the screens, right? But according to me, there are around 3.6 lakhs edge servers of Akamai. Let's say Akamai uses, let's say we use 1 lakh of these servers for YouTube. So now the total bandwidth requirement, if you remember from earlier, we had is 40 terabyte per second. Now this is distributed among a lot of edge servers. Let's consider that the traffic that we are getting is equally distributed. Of course, it will not be equally distributed, but for ease of calculation, let's say the traffic is equally distributed among all the edge servers. So what will be the bandwidth requirement per edge server? Let's say if we take 10,000 of edge server, let's start with 10,000 edge server. What will be the bandwidth requirement by 10,000? Right. So this will cut. This will become gigabyte, and this will become 4 gigabyte per second. Achievable, still achievable. 4 gigabyte per second is easily achievable. If you take 1 lakh, then this becomes even less, right? So this is how the bandwidths get distributed among edge servers, and that further helps you reduce the bandwidth required, right? So essentially CDNs help you with both the cases of first help you provide low latency by reducing distance, and then also second by solving the bandwidth problem, right? Now let's summarize everything, right? Let's summarize everything to make it work, right? You have learned multiple aspects till now. How does streaming will work for a single user, and how do you going to scale it? Let's summarize everything. So let's say here is the AWS server. This is known as origin in terms of the CDN terms, right? Let's say this is the user. Let's say this is the user in Delhi, right? So what will happen? The user will go to watch a video in the Delhi CDN. If the user is from Delhi, it will go to a Delhi CDN. If the video is not present in the Delhi CDN, then CDNs work in a hierarchical format, right? CDN works in a hierarchical format, right? If the video is not here, it will go to the North India CDN. If the video is not still here, then let's say it will go to the India CDN. If it is still not here, it will go to the origin and gets the video, and then cache it at all these places and then return the video. So for the latency for Rajat, like let's say this is Rajat, will be high. But let's say there is another user Manav who is now watching it from Punjab. So now the user will go to the North India CDN directly. And now since the North India CDN already have this video cache, this video is immediately returned to Manav. And the latency for Manav will be low. And this video again, which is going to be here, is going to be chunkified, which will make sure that for a single user, it is working very, very fast. That is how you design a system like YouTube at scale, right? So if I just complete everything and talk about what we discussed today, is this. As we discussed in the agenda, we started with discussing how to design for a single user, right? We talked about this, and then we understand what are the problems you will encounter when you scale, and then what are the solutions to these problems, right? Yeah, so do let us know in the comment section, how did you like the video, or did you learn something new from this video? If there are even any suggestions that you think that we might miss something, it's a very big topic to be covered in just one single video. So I have deliberately missed some of those aspects. So if you even have those that you want me to cover something more in more detail in the next video, we can definitely take that up. Do let us know in the comment section. Also, again, we post 3 to 4 videos every week about data structures and algorithms, about system design, about providing you the right guidance, connecting you to people who are working in the industry. So do subscribe to the Bosscoder's channel. Yeah, I think with that, thank you very much for joining in.